Well, hello everybody, and welcome to MiniLec3. I really wanted to give you guys some extra help with Project 3. I've heard some of your comments, I've gone through the discussions, and Project 3 is probably a little bit intimidating to you guys because it's sort of a blank slate, right? Up until now, you've had a lot of structure behind your projects, and you guys definitely know the fundamentals of code pretty well, but I really wanted to focus on that higher level stuff today. We're going to have a little bit of details, but mostly I want to focus on how do you structure your project and testing, as well as preparing your project to submit, okay? I want to give you some ideas. You don't have to use them exactly, as long as you fulfill the requirements for Project 3. I love creativity. I love seeing people think outside the box. So, you know, if your code meets the Project 3 standards, like if the outputs are correct, if I can query your code, I'd love to see what you got. But here's something to get you started. What are we going to focus on? I want to first cover software architecture for Project 3. I want to think through two examples of Project 3 high-level code. We're then going to go into concept demonstrations. There's two things I want to show in particular, which is reading and writing files, and also the continue keyword, both of which are going to be discussed in the Monday discussion. But today we are just going to go over them as well. We also have testing. I'm going to touch on that just very briefly. And then again, very briefly touch on prepping your file for submission. Software architecture. Why is software architecture important? Well, again, we don't have a template, right? We need to know where to put our code. Are we going to put our code all in one file? Are we going to create functions? How are we going to split it up? This is really important for us, especially in Project 3. So let's think through some examples. But first, we actually have to talk about the example code we're going to be working with. I'm not going to go through a real Project 3 question because I think that would make it too easy for you guys. What I am going to do is create a separate example of Project 3. In this Project 3 example, we are receiving a text file from the library, shown here, with a list of finds. We're going to parse this parse this into a dictionary, and we're going to do the following in whatever order. We're going to save the dictionary to a JSON file. We're going to create a function to get all finds for a student based on the UID. And we're going to create a function to query the total find amounts in the file. So create the sum, okay? We're not going to do that all on camera here. But I want to show you how we can actually structure this project conceptually. What do we need to consider when structuring a project? We need to build a dictionary or index, and we need to save this. Okay, so that's the first thing we need to consider. We also need 2 or more functions to query that index. In this case, we need 2, but one of the Project 3 examples has 3 functions that are necessary. We also need to run these functions independently of one another. So we need a way to be able to run one of them without running all of them. So I'm going to give you some high-level diagrams and walk through these with you. This is not the same as our problem formulations, although it is sort of a problem formulation, but really a very high-level outline. It's the architecture of our program rather than the nitty-gritty details. Again, in your Project 3, you don't have to choose these ideas exactly. Feel free to base your ideas on them, to modify them, or just to do your own thing. Let's start with idea 1, which is totally independent functions. There's 2 important characteristics of this. Everything is a separate function call. So you build the index by the user manually calling the function, and you query the data with the user manually querying the function. The second characteristic, because all of them are completely separated, all functions have to start by reading a file. The original text file is used for building the index. And the output of the dictionary builder, which is the JSON file, is used for the querying functions. So let's start with a little diagram for building the dictionary. This is using a similar format to which you've seen before. It's a little bit modified because it's a different context. But on the left-hand corner, we have the user, and they manually call the build dictionary command. Okay, so this build dictionary command, I suppose, is actually a function. I've included everything inside of that function conceptually in this box. All right, and we still have our processes in here. We first have the read file operation, okay, 1.0, which pulls data from this data.txt file that we'll be working with. That data will go into the program. It'll be read as lines. So these lines of text will go into the second process, build dictionary. Very high level, no details in here. You've already done that work in your problem formulations. So again, this is just the architecture. The dictionary is built properly, and then this dictionary goes into process 3, which writes the file into finds.json, okay? So again, very simple. The user basically calls the build dictionary function, which will read data from data.txt, build the dictionary, and write the file. Nothing else. So there's two query functions we mentioned. The first one gets the finds for someone with a specific UID. On the right-hand side, we actually see the tail end of our previous function. All right, take a look on the left here. The right here. And this is the end of that function. These two functions are connected, but not directly. They're only connected by the finds.json file. This is written by the previous function and is read by this getUserFinds function. The user here, shown on the left, manually calls this getUserFinds with the UID. So what happens then, this is a very simple function in terms of its diagram. The file is read, just like in the previous one, this finds.json. This is parsed into a dictionary automatically by json.load. And then we just find the UID, and then we return the user data from there, okay? This probably should say something like find data based on UID, right? We already know the UID, but hopefully you get the idea. Query function 2 is very similar. Again, we're starting at the tail end of our dictionary builder. The user calls this function, this time with nothing, because right now we want to get the total amount. So what happens is first we read this finds.json file, which will give us a dictionary. We will then sum all the finds, and then we will print out the total find amount to the user. So that is our function there. These three completely separate functions that all read files, and they work together essentially through sharing that finds.json file, which is sort of intermediary data. What does it look like? All right. Well, how do we actually use it as the user? All right. And this is what I would have to do if I was running your functions, for example. Well, there's three things we'd have to do. First, we'd have to build the index. We'd then have to retrieve the total amount of finds. And then we'd have to get the user finds data for a specific user. In this case, this is the user ID I am choosing to use. So here we have our build index. So we're calling build index with the input file of data.txt and the output file of dictionary.json. Okay. I think I had it as finds.json in one of the pictures, but again, this can be whatever you want it to be called. We can then calculate all finds amounts by you calling the get total amount dictionary with the input file, notice, being the same as the output file of the last function, right? Because this is sort of our intermediary data. We then have get user finds data which needs two arguments. We again have the input file here, which is dictionary.json because we need that data, but then we also have the user ID here, okay? And yeah, and as a note, I should have included UID equals here or removed this argument here. You actually can't have a positional argument after this. So my apologies for that, folks. So that's our first idea, all right? But we have another one here, integrated functions. What does that mean? Well, it's a little bit tidier and more advanced version, but it'll make your life a little easier in some other ways. Unlike the previous one, the user only interacts with the querying functions. Right? They don't touch the build index or build dictionary. The query functions then interact with the dictionary building function on their own. The advantages are that it's simpler to use as the end user, and you only have to read one file. You only have to create the code to read one file as the programmer, which is nice. You don't have to do any sort of JSON.load or whatever. All right, so let's take a look at it. And this is sort of a mishmash because again, it's integrated. So we have all of our things here. We're actually going to start with the get total amount function here. We also had that in our previous example. So on the right, the left, the user calls the get total amount function. First process, instead of reading a file, we're actually getting the dictionary. From where? We'll see that in just a second. But then after we get the dictionary, we will sum all of the finds and then print the total sum out back to the user. I'm obviously hiding something here, right? This get dictionary function needs to get it from somewhere. And we see these lines partially hidden, but we see we're giving the input file path to something and we're getting a dictionary back from something, okay? And hopefully you can guess that this is the build dictionary function, very similar to the one that we just looked at with some additions. Okay, first of all, we're getting the input file path as in the user input, which we actually had before. We didn't show it on the diagram. But we are getting the input file path, then we're reading the file data.txt, which should have the same name as the input, right? After that, it's parsing that into lines, which is then going into the build dictionary process. The build dictionary process will give the finds dictionary, which will be written. But notice there's sort of a parallel workflow here. It's writing it to finds.json, therefore fulfilling one of the requirements for project 3, but it's doing something else too, which is sending back the finds dictionary back to get total amount. And I notice I put after 3.0 here, right? Because this is actually done with just a simple plain return statement of build dictionary. The other one didn't have a return statement because it didn't need one. It just wrote a file, that's all it did. But here we are returning a dictionary as well as writing the file. So what does this look like? And it's a little bit different. First of all, we don't have to build the index manually because that is called separately by each of these two functions. But notice here, something else has changed. Input file equals data.txt. If you remember, to each of these separate functions, it used to be dictionary.json as the input. But now, because this is being called, calling the dictionary builder, we are now passing the input file to the dictionary builder. And I've corrected the UID here, is now done correctly with a keyword argument, or again, you could just remove these entirely, okay? So these draw.io diagrams that I've shown you are gonna be on ELMS week 14. So that's the overall architecture of these two example architectures for your project 3. So feel free again to use them as you wish. Now let's go into some concept demonstrations. What I really want to do here is I want to first read the file. I then want to demonstrate the continue keyword, and then I want to write JSON. What I want to do first is show you folks how to get started on this. What I would personally do is go to your desktop and create a new folder. And I'd say it your name, and then perhaps underscore project 3. And this is where all your stuff is going to live. There's nothing in there right now, but I would suggest your first step be to download the input file from ELMS and drag it into this project 3 folder. That'll allow you to access the project data from your project. Okay, so now that we have that open, let's go to Jupyter Lab. So we have Jupyter Lab opened up. I want to start out with the examples.ipynb file, and I want to start with reading a file and using the continue keyword. The reason I'm doing this specifically is in project 3, you may or may not encounter a time where you need to skip data in your input file. Take a look here. Okay, this is our fines and fees from the library as mentioned before. Okay, and as we're going through this file, we're going to want to read each one of these lines and pull out specific data. In this case, we want the fine fee amount, which is here, as well as the UID, which is here. Okay, notice something. The first line is not like the others. This actually doesn't have a UID and it doesn't have a fine. The problem with that is if we try to pull the UID and the fine amount from this line, we're probably going to get some sort of data error. If we're doing a split function, well, we're not going to have all the required indices. And if we're doing regular expressions, we're not going to have a match, right? So there's a number of problems with that. So really, we just want to skip this line and say, for example, if there was another line like this wouldn't be true for this type of file, but perhaps in another type of file, there could be another type of line you want to skip. So what I want to do is I want to read through this file and I want to skip any line that starts with the asterisk in this case. Now, you may have a different condition for skipping a line, but in my case, I want to skip everything with an asterisk. So how do we do that? Let's start by reading the file. As I mentioned, I want to loop through each one of these lines. So we're going to use the readLines function in read mode with open data.txt in read mode as file object. All right, now we have our file object accessible. So we have find lines equals file object dot read lines. So that's going to give us a list of strings. So what happens when we iterate through this? For line in, well, we can just say for fine in find lines. A lot of alliteration, I suppose, in this one. Let's just start by printing fine. When you're doing your project 3 code, you may genuinely want to start simply by printing just to see what you get. Okay, look at that. So we have a line here, a line here, a line here. Okay, but notice two things. First of all, we have some sort of line breaks. Look, there's an empty line in between each of these, so that's something we want to account for. And second of all, we still have these lines with the asterisk in them. All right, so let's first talk about the continue keyword. In a loop, the continue keyword will skip an iteration and move on to the next iteration. So we can pretty simply actually skip the asterisks by doing something like if find.starts with, what do we want to say it starts with? An asterisk. So the condition will be continue. And that's basically say, forget about it, we don't want to consider it. Let's run this again. All right, look at that. So we have actually removed all of our asterisks here. So it's just the finds. We're not going to get any more errors. Now, one other thing we can do, folks, if you remember from the lecture, is when we do this read lines, we are actually, subsequent lines start with a -n, which is why we're seeing this behavior here where there's an empty space in between. And think about how you might actually remove that -n. You may not need to do it for your project, but you may need to do it depending on the output results of your dictionary. So consider that you can remove the leading -n in these lines, and you may or may not need to do so. All right? So that's a demonstration of this here. And I'll minimize this output here. I'll leave this non-minimized. I've minimized the output just by clicking this bar to the side. I just want to quickly go over writing JSON as well. Relatively simple. But I'm going to just write it to a new file here. All right. First, we need to do something called importing. Import JSON. And then we can just open this, open a file in write mode with open. Let's say new file and .json. That extension is important. In W mode for write as file object. All right. And then we can just do JSON.dump file object. And then we can pass our dictionary in here. And I have reversed the order, right? You may see this error as you do this. It's pretty common. Just remove this. Let's put dictionary first and run this again. There we go. If we now look in the left-hand side of our Jupyter notebook or our Jupyter lab, we can see our new file.json, and here it is. All right, excellent. So I'll just save this here and we will move on. So we've gone through reading a file. We've demonstrated the continue keyword, which is we can skip an iteration, and we've looked at how to write JSON. All three of these things are going to be important for your project 3. Now let's talk about testing, okay? Testing is really important. Testing it has two benefits. First of all, it makes coding easier. So it will make it easy to tell when your results match as you continue to work on your code. It also verifies in different cases that your function works. So how do we test? In a separate cell, create some if statements that compare the results of calling your function with a specific value to the expected results for that value. You can call these tests as many times as you want as you code. Pro tip, create the tests first. You don't have to do that, of course, but it will make your life easier. It's called something called test-driven design. All right, so I will show you how to do something like that. I'm going to open project 3 code, and I'm not going to expand this for now because I have worked to create some code that will probably give away a lot of stuff. But basically, let me just show you the function header and definition. I'm going to open this one up. You can ignore this one. This is the build dictionary function. Okay, it builds the dictionary using the input file and an output file. And it's kind of like what we mentioned in some of the previous sections. Yeah, and it's going to return a user finds dictionary. So it's a little bit similar to our second idea, where we are both writing the file and returning the dictionary. So what I want to do is test this function. How do we do that? Let's take a look at our data, right? I'll delete this line that we introduced in the previous one. And we can look here and say, what is a good test? In our output dictionary, say our dictionary is comparing, is holding the total finds for every user based on UID. Let me pull up this dictionary here, because this is actually the output. So we've got the UID here, and it is associated with a specific numeric value, a float, okay? So what we can do then is create some tests to make sure that our dictionary is done correctly. Let's take this user right here. I'll just copy their user ID. They have the value 99.5. So I want my resulting dictionary for this user to have the value of 99.5. Pretend I haven't done any coding yet. All right, so I want my, let's first get our result dictionary. Okay, so the input file is data.txt, and the output file is just going to be output.json again. So this gives us the result dictionary to work with. Again, as I mentioned, this is more similar to idea 2, where it both outputs it as a file and returns the result dictionary. So now that we have the result dictionary, we can do some tests on it. Okay, so let's do something like user find amount equals result dictionary dot get. Let's get the data for this specific user, and if this user isn't found, we will return user not found. So what we can do in that case is say if user find amount not equal to the expected value, which is 99.5, print right error. Let's do an f string, and we can print some sort of message, right? User, user with ID, copy this in, had incorrect value, and then we will paste user find amount in here and fix this horrendous spelling. All right. So if we run this here, let's see what happens. Okay, so nothing happened. That probably means it worked, but we might want to include an else statement, right? Else print test1 passed or something. All right, so test1 passed. Now say we wanted to assert a user with a different ID was in there. Say we expected a user with this ID. I've just changed one of them. Now this user actually isn't in the output, but say that it should be. If we run this again, we'll get error. User with ID here had an incorrect value, user not found. Okay, and this should be updated again with each test. Okay, so we easily can tell what the issue is here. So now we could go back through our function code and say, okay, well, we expected this user to be there. Why is it not there? So this is a good way to do it. We'll also see the other error, right? So let's say it was this user. Back again, we'll change this back to 7. And say we are expecting the value 125. and we run this, we'll see error user with ID X had incorrect value 99.5. Great. So this is an easy way to test. I suggest creating a few of these tests. You could create them for your dictionary builder, but you could also create them for your querying functions as well. And it'll look very similar. The result will equal calling your function with specific values, and the outputs will look like this. So create a slew of those, do some testing, and you should be just fine for your final submission. So I'll save this here, I'll minimize this, and we'll go back to our last little bit here, which is prepping for submission. It's really pretty simple. First of all, make sure your folder name includes your name on it. This just makes my life easier when I'm grading. You're going to want to check that all required files are there, and then you're going to compress the file into a zip file. I'll show you how to do that. So here's your Jupyter lab. You've been working on stuff. Here's a file that I created during this example, so I'll just delete it. So I've looked in here, I see there's my original data input, there's my output, and here's my project 3 code. I've made sure that this file is not empty as well. So what I can do then is go back to my desktop where I originally had this information. Here's my project 3 folder. If I right click and I click compress, it'll create a little zip file, and that's what I can update. But make sure you've gone through your file and you actually see things in here. Make sure that they actually have stuff in them, right? So there's some sizes here. This will work a little differently on Windows, but it will be pretty similar conceptually. So this is the final file that you can submit. All right, folks, that's all I have, and feel free to ask me any questions. Hopefully this is helpful in your Project 3 saga.